So hello friends, let's continue with our objective solutions. Question number 121 asks the ratio of the liquid limit minus the natural content of a soil to its plasticity index. Yes, so we can say WL minus W by IP. This is consistency index. Yes, so you can say this as the answer will be option number D, relative consistency. Next question 122, when the particles of soil are oriented edge to edge or edge to face, which of the with respect to one another, the soil is said to have single grain structure, double grain structure, honeycomb structure or flocculent structure. So when the particles of soil are edge to edge or edge to face it is flocculent structure. Yes, dispersed structure will be parallel to each other. Yes, dispersed structure will be parallel to each other. Honeycomb structure is like this, it will be something like this. Okay, this will be honeycomb structure. Okay, so in flocculent structure it is edge to edge or edge to face. So the answer is flocculent structure. Soil containing continuous voids is called dash soil, permeable soil or impermeable soil. Of course it is permeable soil, because through the continuous voids water can permeate or infiltrate. Okay, which of the following is highly permeable? Gravel, sand mixture, coarse sand or clay? For obvious reasons it is gravel. Yes. Which of the following is practically impermeable? Clay is practically impermeable. Okay, a sample of clay and a sample of sand have the same specific gravity and void ratio. Their permeabilities will differ because their porosities will be different, their densities will be different, their degrees of saturation will be different, the size ranges of their voids will be different. So even if they have the same specific gravity and same void ratio, their void sizes are different. The voids of the sample of sand is, the size of the voids of sample of sand is greater than the size of the void of clay. Okay, the property of the soil mass which permits the seepage of water through its interconnecting voids is called permeability. Yes, it is called permeability. The unit of coefficient of permeability is same as that of the velocity. Yes, coefficient of permeability and velocity has the same unit. It is either meter per second or centimeter per second. Okay. Next question, when applying Darcy's laws to soils, it is assumed that the soil is incompressible. Yes, correct. Soil is homogeneous and isotropic. Yes, correct. Flow conditions are laminar. Yes, correct. So the answer will be all of this. The value of permeability dash the direction of flow of water through the soil mass depends upon or does not depends upon. Of course it depends upon, because one is the horizontal flow, one is the vertical flow, and we all know that KH is greater than KV. Yes, permeability through horizontal layers is much greater than permeability through vertical layers. Okay, so the next question, which of the following have an influence on the value of permeability? Grain size, void ratio, degree of saturation, all of this. So the answer will be all of this. There are several empirical formulas. For example, Allen has an formula. Allen has an equation says K equal to C d10 square. Yes, K equal to C d10 square. D10 is the grain size. Yes, effective size of grains. So next there is a Taylor's equation. Yes, Taylor's equation says that K is equal to C e to the power 3 by 1 plus E. E is here void ratio, so it depends on the void ratio. Then for saturation we have, if the soil is fully saturated, there will be more permeability, the soil will be more permeable. Okay, so it depends on grain size, it depends on void ratio, it depends on the degree of saturation, so it depends on all of this. Next question, if the direction of flow of water is parallel to the planes of stratification, if the direction of the flow of water is parallel to the planes of stratification, then the permeability is dash times more than the direction perpendicular to them. So KH is how many times more than KV? KH is how many times more than KV? KH is generally 2 to 30 times more than KV. Okay, KH is generally 2 to 30 times more than KV. Next question, the permeability of a given soil is directly proportional to the average grain size, inversely proportional to the average grain size, directly proportional to the square of the average grain size, inversely proportional to the square of the average grain size. So we know, just we have talked about ln-Hessian formula, K is equal to C d10 square. So K is proportional to d10 square. Yes, directly proportional to the square of the average grain size. Okay. So the next question, coefficient of permeability of silt is less than that of clay. It is less than that of clay because clay is almost, pure clay is almost impermeable. The coefficient of permeability dash with increase in temperature. Does it increase or does it decrease with increase in temperature? It increases with increase in temperature. Okay. So the next question, the quantity of seepage of water in a soil medium is directly proportional to the head of the water at upstream, inversely proportional to the head of the water at upstream, directly proportional to the coefficient of permeability, inversely proportional to the coefficient of permeability. So it is directly proportional to the coefficient of permeability. Okay, because we have seepage formula as Q equal to KH NF by ND, if you remember. Yes, NF by ND. Okay, so it is directly proportional to the coefficient of permeability. Next question is the average velocity of flow that will take place through the total cross-sectional area of the soil under unit hydraulic gradient is called. The average velocity of flow that will take place through the total cross-sectional area of the soil under unit hydraulic gradient is called, we all know it is called coefficient of permeability. Yes, the pressure exerted by water on soil through which it percolates is known as seepage pressure. Yes, the flow line in seepage through a soil medium is defined as, what is the flow line? Flow line is defined as a path of particles of water through a saturated mass. Yes, flow line is defined as a path of particles of water through a saturated soil mass. And equipotential line, what is equipotential line? Equipotential line in a seepage through a soil medium is defined as line connecting points of equal head of water. Okay, the seepage pressure always acts in the direction of flow. Yes, the seepage pressure always acts in the direction of flow. Quicksand is moist and containing soil particles? No. Condition which occurs in coarse sand, condition in which a cohesionless soil loses all its strength because of upward flow of water. Yes, quicksand condition, the solution will be condition in which it is a condition, it is not a type of sand, it is a condition in which the cohesionless soil, always remember, cohesionless soil loses all its strength because of upward flow of water. Always remember, for quicksand condition the effective pressure is equal to 0 and critical hydraulic gradient is equal to G minus 1 by 1 plus E for quicksand condition. Okay, always remember this. Next question, flow lines and equipotential lines are perpendicular to each other, parallel to each other, intersecting lines at 90 degree to each other, intersecting lines at 45 degree to each other. So the answer will be intersecting lines at 90 degree to each other. The flow net in the seepage of water through a soil medium is a network of flow lines, equipotential lines, water particles and their movements in the soil. So 144 will be flow lines and equipotential lines. A flow net is used to determine seepage flow, seepage pressure, exit gradient, all of this. Flow net is used to determine all of this: seepage flow, seepage pressure and exit gradient. Okay. Which of the following statement is correct? The flow lines are perpendicular to equipotential lines. No two flow lines or equipotential lines start from the same point. No two flow lines cross each other. All of the above. So the answer is all of the above. Next question. The exit gradient of the seepage of water through a soil medium is the slope of the flow line, slope of the equipotential line, ratio of total head to the length of seepage, ratio of head loss to the length of seepage. So the exit gradient is ratio of head loss to the length of seepage. We can see that HL by L, that is I, that is exit gradient, okay, or hydraulic gradient. The hydraulic gradient provided at downstream side of hydraulic structure such as dam is called downstream gradient, tailwater gradient, exit gradient, any of this. So you can call it as any of this. The critical gradient of the seepage of water in a soil medium, just now I have shown you the formula, that is G minus 1 by 1 plus E, G minus 1 by 1 plus E, but G is the specific gravity and E is the void ratio. A deposit of fine sand has porosity N and the specific gravity of soil is G. The hydraulic gradient of the deposit to develop boiling condition of sand is given by G minus 1 by into 1 minus N. Okay, always remember this formula. The direction of seepage is always dash to the equipotential lines. The direction of seepage is always perpendicular to the equipotential lines. The critical gradient of seepage of water is directly proportional to the void ratio, increases with the decrease in void ratio, inversely proportional to the specific gravity, and increases with the decrease in specific gravity of the soil. So the answer is increases with decrease in the void ratio. Okay. The critical gradient of the seepage of water dash with the increase in specific gravity of soil. The critical gradient of the seepage water increases or decreases with the specific gravity? It increases with the specific gravity. Since we know ICR is equal to G minus 1 by 1 plus E. Okay. So the next question, seepage force in soils is proportional to head loss, proportional to exit gradient, perpendicular to equipotential lines, all of this. So it is all of this. Okay. Next question, seepage pressure is independent of coefficient of permeability. Yes, seepage pressure is independent of coefficient of permeability. Next question, the critical gradient for all soils is normally, the critical gradient for all soils is normally 1. Okay. The maximum permissible exit gradient is the critical gradient divided by factor of safety. So it is true. It is the maximum permissible exit gradient is the critical gradient divided by the factor of safety. Next question, the expression for discharge Q through a flow net for isotropic soils is given by KH NF by ND. Yes, KH NF by ND. Next question, a flow net constructed to determine the seepage through our dam, which is homogeneous but isotropic, gave 4 flow lines. Okay, so NF is given as 4 flow lines, NF is given as 4 flow lines, and 16 equipotential drops. ND is given as 16. ND is given as 16. The coefficient of permeability in horizontal and vertical dimensions, this is KH, this is KV. Okay, this is KV. If the storage head is 20 meter, this is H, then the seepage per unit length of the dam will be. Okay, we all know that Q is equal to KH NF by ND. Yes, find the K value from horizontal and vertical. Okay, find the K value and put all the values, you will get the Q value. Okay, put all the values, you will get the Q value. Solve this and write in the comment box below. Okay, I will check it. So the next question is, the permissible exit gradient for safety against piping which endanger the stability of a hydraulic structure should be. So the permissible exit gradient should be around 0.2. Okay, so for today, this much is for today. We will continue the class in the next video. Okay.